Now this is the continuation of our last class. Now here we will discuss about moving target indication radar. In the last class we have studied about one of the classification of pulse radar, that is the basic pulse radar. Now the second classification is MTI radar or moving target indication radar. Okay. Now, as the name suggests, if the radar is used for detecting movable target, then the radar should receive only echo signal due to that movable target. Now, why? Because this echo signal is the desired one. However, in most of the practical applications, radar receives echo signal due to stationary objects also, in addition to the echo signal due to the movable target. So, those echo signals that you receive from stationary objects such as land and sea are called clutters. And these signals are just unwanted signals. We don't want that. So, therefore, what we have to do is we have to choose a radar in such a way that it considers only the echo signal due to movable target and not stationary object. Okay, for that purpose, radar make use of the well-known principle Doppler effect just for distinguishing the non-stationary target from stationary object. Such radar or this type of radar is called moving target indicator radar or simply MTI radar. According to Doppler effect, you all know that if the frequency of the received signal, that is the frequency of the received signal will increase if the target is moving towards the direction of radar. Similarly, frequency of received signal will decrease if the target is moving away from the radar. That is the Doppler effect. So they have written this in a very simple way that you can easily understand. Hope it is clear. Now let us discuss about the type of MTA radar. There are two broad classification, coherent and non-coherent. Then coherent radar, it differentiates between moving target and stationary target using the principle of Doppler shift. Whereas non-coherent radar detects moving target by means of the relative motion between the target and the stationary object or clutter background, and thereby uh, the corresponding amplitude changes, that is according to the corresponding amplitude changes from the pulse to pulse or from one antenna scan to the next. So that means coherent MTI radar differentiates a moving target from a stationary target using the principle of Doppler shift, whereas a non-coherent MTI radar differentiate between a moving target and a stationary target using their relative motion between the target and the clutter background. Okay. Now in coherent system, the phase of transmitted wave will be saved, whereas in non-coherent that is not needed. Then so that is a broad classification, non-coherent MTA radar and coherent MTA radar. Here they are explaining about non-coherent MTA radar once again. This type of radar uses amplitude fluctuation instead of phase fluctuation. Here an internal coherent reference signal or phase detector is not needed. Here they use an IF amplifier, and that should be linear and must have a large dynamic range. Then amplitude detector is used after the IF amplifier, and this amplitude detector is a conventional detector. Then the last one, the local oscillator, that need not be very stable. So this is a block diagram for a non-coherent MTA radar. Now we are interested in coherent MTA radar. It preserves the transmitted wave phase in order to detect the Doppler shift in frequency. Here the Doppler shift in the echo signal from moving target is used to differentiate it from the stationary target that we have already discussed. So now there are two types of coherent MTI radars. One is MTI radar with the power amplifier transmitter. The other one is MTI radar with the power oscillator transmitter. This is a block diagram of MTI radar with the power amplifier transmitter. Now these are the functions of each block. One is pulse modulator, it produces pulse modulated signal. Then power amplifier, it amplifies power level of the pulse modulated signal. Then local oscillator, it produces a signal having stable frequency. Then the output of local oscillator is applied to mixer 1 and mixer 2. Then there is a coherent oscillator, it produces a signal having intermediate frequency, and that signal is used as reference signal, and its output is applied to both mixer 1 and phase detector. Now what is mixer 1? It produces either sum or difference of frequencies that are applied to it, that we have already discussed in the last class. That is, the signals having frequency F, L and Fc are applied to mixer 1. Here the mixer 1 is used for producing output having frequency FL plus Fc. Then duplexer is a microwave switch. It connects antenna to either the transmitter section or receiver section based on our requirement. Then antenna, it transmits a signal with frequency FL plus Fc when duplexer connects antenna to the power amplifier. Similarly, antenna receives the signal with frequency FL plus Fc plus or minus Fd when it is connected to mixer 2. Now what is mixer 2? It can also produce either sum or difference of frequencies that are applied to it, and that is, mixer 2 is used for producing the output having frequency Fc plus or minus Fd. Then IF amplifier, it amplifies intermediate frequency. It amplifies the signal having frequency Fc plus Fd. This amplified signal is applied as an input to the phase detector. Finally, phase detector is used to produce the output signal having frequency Fd from the two applied input signals with frequency Fc plus Fd and Fc. These are the two input signals. The output of phase detector is connected to delay line canceller. So this is the function of each of the blocks that is described in the block diagram. Now this is the working. Here the power amplifier, one of the blocks, is used as the transmitter. Now two local oscillator, their function is to provide reference signals to the mixer. There is a coherent oscillator and it is a stable one. It has a frequency same as that of the IF amplifier, which is used in the receiver. The output of coherent oscillator is mixed with its stable local oscillator frequency. Then there exists a phase detector after the IF stage. Then this act is similar to a mixer in which the received signal coming from intermediate frequency or IF amplifier and reference signal from coherent oscillator is mixed to produce difference between the frequencies. That is, in the mixer stage we have already discussed, that is, in IF amplifier they just mix the two frequencies, especially the different signal, and this difference will be the Doppler frequency, and this input signal is applied to the power amplifier will be the sum of coherent oscillator frequency and stable local oscillator frequency. So here we have seen some FL, FC, etc. right? So that FC denotes this coherent frequency, D is the Doppler frequency, then L is the FL is the local oscillator frequency. Okay, that was what I mentioned. That is, FD stands for Doppler frequency, FL stands for stable local oscillator frequency, FC stands for coherent oscillator frequency. Okay, so once you mention this, you will be able to understand this description also. Okay, it's nothing but they are mentioning about the various oscillator amplifier stages and their function, especially with the due importance to the function of IF amplifier, intermediate frequency amplifier. That is, it's the they are mentioning that the function of IF amplifier is similar to that of a mixer, where the frequencies are mixed, or sometimes their difference is taken, and the final output will be amplified, and it is called Doppler frequency. Next is MTA radar with power oscillator transmitter. Its block diagram is similar to this, the one that we have already discussed earlier, that is similar to MTA radar with power amplifier transmitter, and the functions of the blocks are also the same. But there is a few difference in the blocks related to the transmitter section. So this is the block diagram which you can go through, and this is the operation. Here there is a magnetron oscillator, and the output of magnetron oscillator and the output of local oscillator is applied to the mixer 1, and this will produce the IF signal. Then the output of mixer 1 is applied to coherent oscillator. This means that the phase of coherent oscillator output will also directly relate to the phase of transmitted signal. The output of coherent oscillator is used as a reference signal for comparing the received echo signal. Now this tasks are repeated for every newly transmitted signal. So among this, the important one is MTA radar with the power, this one, power amplifier transmitter. Okay, but if they are asked to you to write about, discuss about MTA radars, then you will have to mention these two, both. Okay, so their MTA radars are broadly classified into coherent and non-coherent, and we are going to discuss more about coherent. Coherent types are divided again into two. They are MTA radar with power amplifier transmitter and MTA radar with the power oscillator transmitter. Their block diagram, functions of each blocks, and just one paragraph about their working. Okay, now in the last session, these are some of the advantages and disadvantages of MTA radar and some of their applications. Okay, this is most probably asked as essay question. Okay, that's all for now. Thank you.